Okay, so I am here from Building Knowledge Canada, and what we do is we are a trusted source in the home building industry. We have many services. I won't take up too much time talking about us, but we are involved in product training, code training, research projects, presentations throughout the industry that could include the ministry, could include Natural Resources Canada. But mostly we work with builders and help them get through all processes, whether it be building code or Energy Star or Net Zero. Some of those programs you've probably already heard about in your class. We do energy modeling for Ontario Building Code, SB12, as well as national code that's coming along. EnerGuide, Energy Star, Net Zero, R2000. LEED is still around a little bit. And several other services. This year we have made it to 54,000 homes or more that have actually been touched, air tested, and energy rated. So that would be mostly Energy Star and some EnerGuide and LEED in there. So that was a milestone that we had this year. You're welcome to go on our website, buildingknowledge.ca. It has a lot of information about projects we worked on, as well as a good resource for technical information. So there's webinars on there, there's PDFs, different links to other companies that have lots of information, like the guides book. I don't know if you're familiar with the guide site, but there's lots of information about building code and building science and what to do and how to do them. Myself, I'm Angela Bustamante. I don't know how much she's told you already, but I am the Director in Technical Services as well as Quality Assurance here at Building Knowledge. I've been here for a good 15 years. I've been at this probably much longer. I think I graduated from Conestoga in a very similar program to yours. It was construction engineering. I think they've renamed it to architectural. It was a 3-year program. It was a whole lot of everything, a piece of every component of the build. Just like yourselves, I'm sure, there was concrete, there was framing, there was building science, there was lots of drafting, lots of design, mechanical, electrical. I remember coming out of that thinking, I know a lot of something about a lot of things, but not enough of any one thing. And I can assure you that later on, as time goes by, every one of those pieces of courses affects the things that you do in the day-to-day. Even just I'll tell you, the one I didn't like the most was concrete. Concrete pressures and loads and all that. But it's still, when someone's talking about concrete and their problems about it, it still triggers a little bit of memory back from, slump tests and things like that. So it might feel like I don't even know how to say it. Don't worry about not knowing everything about something, and just take what you do learn and apply it throughout the continuous learning that you will be doing as you go along. It is definitely continuous learning, always learning, always. Let's see. Now, what do I actually do? On a day-to-day basis, I am talking to designers, HVAC designers, for the most part builders and their team. So that could be their contracts managers, that could be their VPs, it could be their plans permit provider, could be their trades, could be their site team. We try and take the process. I think you guys have gone through the Energy Star process. This is a good example. That Energy Star process isn't just one component. It starts in the very early stages of that design and goes all the way to that final occupancy stage. For us, we're a little different at Building Knowledge because we are there through all those stages. So we handhold all the players in that field. So, I might start with the builder, someone in our team. We also work as a team, so we have members in our team along that route. We have someone that might work with the builder at the early stages, defining their path or their goals. Maybe they want to be the most sustainable company in Listowel, for all I know. Then we will work along with their construction teams, look at their details, and we'll look at contracts, you know, trying to figure out which component they want to do. Do they want to do exterior insulation? Are they, you know, do they have a mechanical HVAC designer yet? Do they have an installer yet? Is there certain equipment that they like or not like? And then we might start, once we figure that all out, we might help them with building permit and give them an Energy Star BOP. I think you guys were making some BOPs probably earlier. And then we would also help, once that goes in for permit, we would do some team training on site, working with their trades and their construction teams all about air tightness, and just not so much why they're, oh well, sorry. We explain to them why they're doing Energy Star and why the air tightness is a factor. And it's really not about being an energy label or an energy program. It's really all about that great building science you were learning about and how it affects their product in the end, and their quality assurance in their end, their home comfort for their homeowners, etc., etc. And then we get to give them a label as well, so we work with that. There's a lot to do. And lots of jobs in between, lots of opportunities for students coming out for sure. But today I'm not going to tell you about all parts of that because I could go on for like forever. And it is Friday, so I'm talking like super fast. So if you need me to slow down, let me know. But today I'm just here to help you with going through SB12 specifically. It's something that right out of class, if you are doing, thank you, Bustamante. When you are out of class, maybe you're going to be in an architectural office or in a builder's office. Those are potential. You might even be helping on site. Either way, the SB12 is very important when it comes to the construction industry. For Part 9, I should specify, there is an SB10 for commercial Part 3. We tend to shy away from that. The SB10 is very involved with engineering. You know, you have your structural engineer, architectural engineer. So everyone has kind of their components to it, whereas SB12 is all Part 9. So these are all your houses, your MERBs, your detached, your attached, some live works. And it can get quite complex. So I'm hoping to take some of that complexity out of there and just give it to you kind of plain and simple for the most part, and some direction on where you could go with it as a new grad. So, and you've taken the SB12, I think. You reviewed the SB12. So this is just going to be a quick overview, and then we'll jump into the packages. So there are 5 kind of components to it. One was the prescriptive path, so that one's fairly easy. That's your A1 to A6, and we'll go into these a little bit as I flip through the slides. But so we have the prescriptive path. That's the builder goes in, says I'm doing A1. This is it. That's all. That's what we got to do. Now, and there's no air tightness. There's no air testing belonging to that. Air tightness trade-off is the next one. Not popular whatsoever. I don't have a single builder that I know that has taken this. Basically, the air tightness, if you do a certain air tightness, you can trade off some of the components in the prescriptive. I'll bring up that chart in a minute. Performance path, we will get into more detail, and that's the alternative route where you do energy modeling. Very popular. And then we have the other acceptable compliance methods, which is your Energy Star or R2000. R2000, not very popular. Actually, we had probably the most R2000 builders in Ontario, if not, I'd say the country, except out east, they still do some R2000 out there because they have incentives through the hydro and the other utility services. But here we have actually lost, I shouldn't say lost, our R2000 builders have all developed into net zero builders, so that's very exciting. So yeah, we're gonna do that. And then number 5, there's some other things that we will talk about that are stuck hidden in that SB12 a little bit. that comes up in our day-to-day. So prescriptive path, that's your A1 to A6. Of course, these charts come in your metric, your imperial, they come in zone 1, they come in zone 2, and then you have one for the gas and propane, you have one for oil, and you have one for electrical. The only thing I have to say is be careful with that, because when you go and if you're just going to choose a package, you have to know what that mechanical is, because as soon as you, if they're going to decide to go with a hot water heater and a furnace that's electric, then we have a problem. Then we're into the other charts, and it can get a little ugly sometimes. Fiber boards. I will take some of those questions after, because then it's going to throw me off reading and talking at the same time. The air tightness targets, these are the trade-offs. You can see that, no problem. The air tightness target, they actually were based on the Energy Star for New Homes target. So that table with the detached and attached, that is the level 1 air tightness for detached and attached. But the trade-offs for it, basically if you take A1 and you do 2.5 air changes on an air test, you can change your HRV to a, let me see, not even the A1. The A1 doesn't even come up. If you had the A1, you could change your furnace with a 4%. So I don't know a builder that's going to risk their occupancy for a blower door test to change a furnace by a whole 4% AFUE. Actually 2%, because the A1 is a 96% AFUE furnace. And generally most furnaces are 96% now anyway, so this table is not very popular. Like I said, we don't have a single builder doing it, just because those trade-offs just did not warrant the cost and the risk involved with air testing. So onto the performance path. So this is the energy modeling portion, and this is the part where the last 2 years our lives have gone crazy. So this is the alternative to an A1, alternative to any of the packages. Definitely a lot more flexibility here. So the HOT 2000, I don't know if you've had the HOT 2000 training within your course. I think George Brown was offering it before at some point. HOT 2000 is the Natural Resources Canada's software for energy efficiency. We go through many versions of it, but that's a different story for another day. Basically, another performance path, we would take a model, or hopefully the plans are somewhat close to finished, and we would model the house, and we would do it as a code package. So generally speaking, A3 is the worst performing package, mostly due to the domestic hot water being only at a 0.67. So that takes a big jump in the file. It's usually about 2% difference from the A1, but under this path we are allowed to compare it to any of them as long as we are in the same zone, same energy. So for example, if someone is doing electric heat, you can't take their file and compare it against an A1 in the gas table. I have to go and take it to compare it into the electric table under, like, I don't know, C3 or something like that. So basically, yeah, we model the house, we would do it to a code package, say A3, and you're going to see this in a few minutes, but we'd do it to the A3, and then we would take what the builder would like to do, and we would work very closely with their team, deciding, did they want to change the basement, did they want to change windows, did they want to do away with the drain water heat recovery. That is actually a mandated part of the prescriptive path only. We do a lot of files that are just taking away the drain water. So basically the A1 package, if you were to do that with a better condensing tankless hot water heater that usually has a efficiency of like 95%, say, generally you can model that exact same model without a drain water and beat or be better than A1 and A3. It might be obvious a little later when we get into the chart. The other method is what comes in is the other acceptable compliance methods, and this is where Energy Star comes into play. They have currently listed 12.6, and they did not say or newer. Little tricky, but we are still glad to see it in the SB12 back in 2012 when they brought it in. I think you were learning about the version 17.0 and 12.8, something like that. We are now just started another version, 17.1 revision 2. So sometimes when I go into the building department with a BOP, they like this very specific wording that says 12.6. So even though I'm not having the builder build to 12.6, I have to adjust my BOP form to make it look like a 12.6. Just because it doesn't say or newer. But so this method here lets us go in under SB12 with an Energy Star BOP form and our energy efficiency design summary form, and we don't have to model any homes. So it's a much faster, easier way for all of us to get through permits and all the models. It's definitely my preferred method and something I do, I would say daily. I'm making at least one BOP for a builder. Anything else? So this is the other thing. So two things. One, it's not on here, but on that chart, that A1 to 6, as soon as that builder is doing a combo heating system, so combined space and water heating, the only package they're allowed to use is the A4. So just looking back at that A4, that is when you automatically have the 1 inch of exterior insulation at a minimum on R5 exterior, and also the drain water heat recovery. So combo heating is very popular under the performance path because of that. Let's go back. So that's one item. The other one is additions and existing buildings. So there is a chart, table 11, I think it's called, yeah, 31111. They recognize that permits for existing homes and addition would not be able to keep up with necessarily all the changes throughout their house. But if they were going to add on new, they would at least like the walls and the envelope to be somewhat better than before. It's actually quite extensive. You look, the zone 1 would probably be the minimum one here. And it's still asking for 19 plus exterior insulation, 1 inch of exterior insulation. It's asking for the basement walls to be an effective 21, so that's like R5 plus R20, maybe 22, or your R10 plus R14. That could add up if you're doing a renovation. It addresses windows, although it's not the best window that it's asking for, so it's not so bad. But what it did do is it left out mechanical equipment. So it said you could build to this if you've left your existing mechanical and you're not doing many changes. But it also said, or you can go back to the other charts if you choose, the A1 to A6, but you need to meet those components. So if you were going to change out your hot water heater, then you might be able to go back to the A1 that had the R22 walls. So there's a little bit more to think about when you're doing additions. How much you're going to change. Are you changing all the walls, some walls? Can you get under the slab? Are they new windows? Are you changing all the windows, etc.? And while we're on that topic of existing homes, there are some big incentives coming down from the government, all based around existing homes, because they found out they're definitely losing a lot of energy. We know it's going to be based on the EnerGuide rating system. So again, the HOT 2000. And air tightness testing. We're just waiting another few months to see what that is going to look like. Sounds like it'll be very familiar to the other program we had recently, not too recently, but Eco Energy, the Eco Energy program. So there was grants for air sealing, attic insulation, windows, changing furnace, changing hot heaters. And the big thing about that program, and they're trying to look at it right now, because one of the big deals about it is what happens. I'm going to test your building science right now. you can imagine going into an existing home and just dealing with the windows. So, you know, they might go from a single pane window to a triple pane window. That will have an impact on that cooling load, so that'll have an impact of the air conditioner. It'll also have, you know, was it air sealed around the windows? What kind of walls were around those windows? So it's, I don't want to focus on one thing, but you can just picture that house as a system approach while doing existing homes, and how it's really important when someone's going through something like that, renovations and upgrades, that they're really working with someone that knows that house as a system, that building science approach, how one item affects the other. And I think you guys are in a really good position to have a lot of that information, and to work on getting even more information as you're faced with different situations. So one of the things we might talk about later is about being an evaluator, which most of us here at the company, we did do the construction programs, but we also went through Natural Resources Canada's process for being energy evaluator. Very important. We can talk about it after. But until then, I will get on to our packages. And I'm just going to try and bring up, nope, that's a builder's net zero house. Don't want that. It's a lot easier when I'm in the PDF than when I'm in the PowerPoint. Okay, there we go. Now I can zoom. So this is what we call the performance optimization exercise. This was based on a detached model. And we might be working with a builder. They might have given us some idea what they wanted or where they're going, and maybe not so much. Excuse me. They might have told us that they're used to A1, but they wanted to work on efficiency. They might have wanted to go Energy Star. They're thinking about net zero. And this is kind of what we do. We take that model, we put it in the HOT 2000 software, and then we break it out in a chart for them that's a little more easier to understand. Hopefully, that's the goal. And I broke this out for you guys so we could kind of go over the same things that we were just talking about. So this is a detached model and modeled in the A1 package. So this is A1. So when it's modeled, this house came in at a 96 gigajoules. That's what that house rating is for total energy. When we take that same model and model it as the A3 package, it's 98 gigajoules, and that's where that 2% difference came in. So generally speaking, it's usually worse performing by a little bit because of the hot water heater, and a little bit less in the attic. That's about the main reasons why. So those two are the prescriptive path. Then we have what we talked about, the performance path. So under the performance path, we usually give them two options. One is, what if you do not do any air testing? So under the performance path, when you don't do air testing, that means you have to, in your A3 or A1 package, building code SB12 tells you that detached must be 3 and an attached home must be 3.5, and they're assumed and they're in both files. So we've left that assumed air tightness of 3, rightfully or wrongfully so. I won't get into that either. But and in this one, I just take the A1 package, and I took the HRV down to a 65% HRV. Sometimes a builder might want a smaller unit. Some of the smaller units tend to be 65%. And I up the hot water heater like I was talking about. This one actually has a UEF rating, which is the new efficiency for hot water heaters. I think it's unified energy factor. Very close to EF rating, a little bit less than the EF. But so this was a UEF of 0.95. And we took out the drain water heat recovery because that's a requirement for A1 or A3. And when modeled, that house was a 98 gigajoules. So it's exactly the same as A3. So we could go in for building permit with 2 Hot 2000 reports showing the before as an A3 and the after as this proposed package. And that would be good to go. So then I also created a package that is what if we wanted to take credit for air tightness just a little bit better. This is a detached product, so 2 air changes. So it must be air tested for occupancy. That means when they're done close to finishing the house, maybe the last week or so, we'd be in there doing an air test, and we would have the volume surface area, and we would have a target of 2 air changes, and we would give them the results. We would provide them with a letter with the results, and they would be good to go. In order to take that air tightness credit, we would hope that they would have some experience or at least some benchmarking. Because like I said, it's for occupancy. So you can imagine if you don't hit that target, what happens then? We might be cutting apart drywall. We might be calling in special services like aero barrier. But anyways, in this case, we're saying maybe this builder already knew what their air tightness targets were like, and they had no problem achieving this. We have several builders that are in this category and actually do even way better than this. So in this case, 2 air changes, and from the A package, all I did was change that R20 continuous insulation, which is usually a blanket. It's not pretty. Maybe they want to frame that basement, put in an R12, so a 2x4 R12. They might call it finished ready or framed up already. I don't know. Obviously, I don't do marketing names. So they might do, an R12 bat, framed, and an air tightness test. And with that, again, we're still at 98 gigajoules. If they would have done a little better hot water heater, we'd probably be way better than even the 96 gigajoules. But the point is, for both these packages under the performance path, they are very flexible packages. So, we might start like this with the builder and look at this, but they're like, oh, you know what, I decided I'm going to put triple pane windows in. So then we might tweak this package to say, okay, triples, who knows what else, maybe we could take away the drain water. It's really like a puzzle game, which is probably why I like it so much. It's always changing, always getting creative. Okay, so we've got prescriptive, we've got performance, and then we've got the alternative methods, Energy Star. So Energy Star, this is just one package that I put together. This is a very common package. It might look a little different in points from what you were just seeing, because this is the 17.1 revision 2, where they changed their points a little bit and the target a little bit. But generally, this is very close to the package under version 17 as well. Only one change that I'll point out in a minute. But this is a very popular R60 Attic, same as A1, R31 for the flat, same as A1. A little different on the exterior insulation. This is with 1-inch insulation on the exterior. That's probably the biggest jump for most builders. And obviously from your building science, one that we try and hone in on. I would say of all the builders that we work with, which is quite a few, we only have about 2 builders that right now are not putting on exterior insulation. So very important factor. Yep, so that's a little different from A1. Not much different from A5 though. If you're looking at A5, this is very close to A5 package. We've got an R20 continuous in the basement. Well, I guess I should have talked about exposed floor. That didn't change from A1 either. That's an R31. Basement doesn't change from A1. Now I've written continuous here with Energy Star. There's no requirement for it to be a continuous insulation, but it is required to be an effective 21.1. So the only real way to get there is either a R20 blanket, which is considered continuous, rightfully or wrongfully so, or they can do something like R5 plus R20, R10 plus R14. So it's not so much about the continuous. I should actually change this wording, and it should say 21.1 effective. Under slab insulation not required unless it is a slab on grade. Again, no different than the A1 or A1 to A6. If you have under slab insulation that's above the frost line, must have R10 under it. That was a change, I believe, in 2017, which was a great change because you know most of the heat loss comes from the slab. Windows, a little bit better on the windows from the A1, but the same from A3. That's a zone 2 window, U value 1.4 or ER of 29. Not a bad window. That's your low E argon, fairly typical window that is installed nowadays. But an Energy Star, that would be the minimum requirement. But you would have no points associated to that. So that's your base core. Energy Star level 1 for a detached, that's 2.5 air changes. Fairly achievable by several builders. It's not that difficult. Again, it does take some work. Attached homes, way different story, but detached for the most part, a builder could pay some good attention and achieve these results. 75% HRV, same as A1, no different. In this version of Energy Star, if you take a little bit better HRV in terms of the fan efficacy, so the liters per second per watt, there's a little extra credit in there this time around, 0.1. That's a little extra bonus. 96 furnace, 96% AFUE furnace, same as A1 again. No requirement on the air conditioner. It's exactly the same as code. Code right now is a 13 SEER, so if you're putting it in, it's just as per code. Hot water heater, that's again that UEF comes into play. In this version, they actually gave a little more points on the UEF. So this hot water heater with a 0.95 UEF is 0.4 points. So it was a little bit of a boost from the old package to this package. For the version that you were looking at, the 17.0, that's really the only difference in our most common packages. This would have typically been a 0.9 EF, and the points would have came out the same. They really derated the drain water heat recovery in the current version quite drastically. You were looking at like a 0.9 points for the 42% drain water, and now we're looking at a whole 0.3 points. They derated them. I will not get into that. But so generally I would not need to model this. That would just be the prescriptive path. However, I did it for this exercise, and you can see that it was 84 gigajoules, which is about 14% better than A3. In general, Energy Star is 15 to 20% better than code. Arguable what the word code means. That could be A1, A3, you know. But generally, it's about 15 to 20%. Now, not part of the SB12. Well, it kind of is part of SB12, actually. I shouldn't say that. There is a component in SB12 for net zero, or at least for reduced operating conditions. So they recognize that there are reduced operating conditions for the net zero. So this is a package that we kind of threw all in here. We've been doing net zero for several years now, since the pilot for the first homes at Reed's Heritage out in Guelph there. There are now 500 homes labeled in Canada under the net zero program. The program is from the Canadian Home Builders Association, CHBA. It's very exciting, and we have many more coming up in the next few years. But through all those packages, so under the net zero program, every home must be modeled. So it's all performance path. When we go for permit though, if they're doing a dual label, which they're welcome to do, we tend to put them under the prescriptive path under Energy Star, because the net zero package pretty much blows away most of the Energy Star. So I'm not as diverse in the reduced operating conditions in the SB12 procedures because we tend not to use it. We use it in the actual file submission to the CHBA or to Natural Resources Canada. But through all those packages, we kind of went through, in general, if you had a detached home and you followed this package, be about 98% chance that you would meet the net zero energy target. So the change is mostly about the walls. That's adding 2 inches instead of 1 inch, a little more in the exposed floor, a little bit more in the basement. Well, I should say this is kind of just what we've come up with. In the net zero program, the minimum requirements are pretty much the same as the Energy Star version 12.6 requirements as a minimum. However, as you're modeling things and changing components, there's a certain target that you have to meet. And under the net zero and the net zero ready, you are doing a solar analysis. So every component that you move might mean you have to put more solar panels on. So the goal is always to try and get as low on the gigajoules so you can get as least as many panels on the roof. So every component plays a factor. So for example, this R22 plus R10 basement, maybe that could be reduced if we had a better heat pump or if we took a better air tightness test. So everything's kind of ever evolving when you're modeling the homes. A minimum requirement though is the R10 underslab, even when it is below the frost line. So that is a bigger cost for the builders. That's probably one of the larger ones. Apparently it's cost quite a bit. And triple pane windows, we're actually not supposed to say triple pane. Generally it's a better performing window and we prefer a triple pane because generally speaking this 1.2 U value tends to be a good triple. However, the minimum would be the zone 2, the U value of 1.4 and ER29. But now that in a net zero home, you're really looking at that whole house's system that we're just talking about and making sure you've covered it all. So this triple pane window, or sorry, if it's not a triple pane window, just looking at the solar heat gain value alone has an impact on the cooling load. And the cooling load impacts how much tonnage that air source heat pump is going to be. And that's where some of the cost and comfort can come late. So it's always important to look at the whole picture. HRV, we generally see ERVs. It's not a requirement, but it's a suggestion that it be an ERV because we want ventilation to run all year round. And we also prefer an ECM motor, or at least one that has low wattage, tend to be in about the 30 watt range. That does impact the file as well. Anything electrical affects the gigajoule total and electrical consumption. This is probably another big change for builders. Not too big, but it's definitely industry disruptor. It's dual fuel, so we have a 96% furnace, so that's a gas furnace, and we have an 8.7 HSPF air source heat pump. So instead of putting the air conditioner in, they put an air source heat pump, and it can cost anywhere from $1,000 to $2,000 extra, I think. Don't quote me. That's what it was. Hopefully that's starting to come down now that we have more homes starting to use them. We get a question often about why dual fuel, why not all electric? And the thing is, it's just right now, cost. The cost of electricity in Ontario is very expensive and it's actually going up. So under the net zero program, we have net zero and we have net zero ready. So a net zero ready house means that you're still designing the house for if it were to have solar. So it has to be still solar ready, still has to have space and room on the roof for solar. But it just means you're not going to put the panels actually on the building. So that's why we like to provide a dual fuel option, because let's say, you know, a builder builds the house this year, but the homeowner doesn't put solar on for another 2-3 years perhaps. that means for the next 3 years they would be operating that house at all electric, and that could be quite costly. And then when they do decide to put on the solar, they could easily switch this out to straight air source heat pump. They could put an electric hot water heater if they wanted to. It's not in this package, but speaking of the hot water, this is just the same kind of condensing tankless we're talking about, 0.95, 0.96, UEF 0.95, same thing. We are starting to see air source heat pump water heaters come into play. In Ontario, we have this thing called rental hot water heaters. All new homes, I shouldn't say all, many builders, at least production builders, that equipment is rented. So that also is something that we look at in cost-wise. They might be doing a cost analysis for the homeowner, so they don't want to give them all electric, and they don't want to give them the higher cost of the rental hot water heater. Drain water heat recovery, here it says 50%. That can range from the 30% up to the 60%, and sometimes not at all. So it's not a requirement to have, but generally in the model, that could sometimes equate to about 3 gigajoules. So that can help take off panels, solar panels. So if you look at that house, it did use the reduced operating conditions in the software. So it helps a little bit on occupant load. This is this gray. So this 48% of this house is all occupant load and lighting, which means no matter what I do to this file, I can't do anything with those. They're just, that's your TV, your fridges, your stove, your who knows what you got going on, but you can't change it. So there's a lot more background and history, that story and where that's going, but it is kind of, it's given us a little headache in the net zero attached and MERB programs, because in an attached home, half of it is occupant load. So I have to have roof space for all the solar, but you can imagine in a back-to-back townhouse how much roof space there is. I'll tell you, it's not enough space. So we're working through that as part of the pilot program. Hopefully that'll come to fruition this year. We have many MERBs and attached coming down the pipeline. So we have to figure it out. We will figure it out with CHBA and Natural Resources Canada. You can see that the net zero was about 50%, 51% better than the A3. So generally, net zero is considered half a code. And also you can see on our chart, we have the number of solar panels. This is just very rough estimate. That house would need, under the net zero, about 41 panels. If we were doing this to A1, it would need about 82. So it's a big difference. It's a big difference. And within the net zero program, not listed here, but there are requirements on the envelope. You can't just take the envelope way down, you know, even to the A1 or under A1, and then throw a bunch of panels on the roof and say, yeah, I'm at net zero. There is a requirement for it to be 33% better than the national reference house. Generally, that comes to about the same minimum requirements as the Energy Star walls and slab and attic and windows, but there's definitely a lot more than net zero, but I don't have all day to tell you about that because I could go on forever. But it is exciting, and it's definitely, as a new graduate, somewhere that you want to be looking at. The CHBA website is an excellent resource, and our quality.ca is an excellent resource. The net zero program is based on R2000, Energy Star. Your house is a system. You know, back from R2000 days, it is that same, you know, 1.5 air tightness. Yeah, it's looking at the whole picture. It's very important. But so working with net zero, you know, CHBA, so if we talked a little bit about things to do in the industry and where you're coming out of school, one of the things to look at is the Hot 2000 program and the NRCan Energy Advisors. Even with the new program, apparently, I heard yesterday, that they will be looking for another 1,500 evaluators to be able to carry out what their plan is for this new program for existing homes. The NRCan, basically it's the NRCan Energy Advisor. There's a foundation exam that's based on your building science, so you should be all right with that one. There's another exam for Energy Evaluator Advisor, so that's their EA exam. That's based on the protocols of NR Guide for New Homes, which is the basis for most of this code, net zero, even Energy Star. So an energy evaluator is something that you might want to look into. If not look into it, at least be part of something like CACE, which is CACEA. It's the Canadian Association of Energy Advisors, but it's a panel of products and industry knowledge. They have members from all over Canada, and it's kind of the one-stop shop for energy efficiency and changes. Lots of information. There's so much information. There's so much. That's the thing, you're never going to stop learning, but definitely look into Hot 2000. There is a free version online. It's in a basics mode, so you cannot put in like full reports. I believe you can get the gigajoule results, but you won't have all the same information that we would have as an EA. But as a designer, just being aware of the different components and what happens to them in the software is going to be huge. I don't know how much you want to get into it, but we also have what's coming down. Oh, this is going to be an industry disruptor. We have National Building Code coming down probably by January 1st, 2024 for building permits. We are still waiting probably the next, well, it was supposed to be a couple months. I think it's going to be even more than that now. National Building Code is working on their 2020 National Building Code. Yep, 2020. And in there is a lot of changes under Part 9 in terms of energy. I don't know how familiar you are with the national current code, but Ontario and Quebec are the only ones that have their own provincial code. But come 2024, we will all be on National Building Code, including Ontario, which will be definitely the disruptor. So try and keep your ear on the ground about changes. That's through CHPA, OHBA, OBOA. Though I'm sure there's going to be a lot of training sessions on it. It's going to be new, very new. It's going to be new to plans examiners. It's going to be new to HVAC designers, to everybody. I can't even begin to explain how much of a disruptor that one is. But the good news is, under national, it's very much like OBC, SB12. The energy portion, so it does have a prescriptive path approach. It does have a prescriptive with air tightness approach, and a performance. And then they also threw in a little thing called NR Guide. So at the moment, Energy Star is not in the national, but NR Guide is. So I'm still hoping it might slip in there. It's actually the first time ever in national, or any code really, that they've allowed for a government labeling program be in the building code. So there's been a lot of controversy about that, and we'll see. Well, we'll see if it even stays. So far it is. One of the big things they're maybe not a good word, contemplating about right now at the national level, is about air tightness. So we talked about air tightness today a little bit, where SB12 assumes the detached and attached. A national reference code in Hot 2000 has always been set at 2.5 air changes, and Oh, I won't get into how they came up with that one time long ago, but it's kind of just stayed there and it's been around. But over time, for companies like ourselves that have been working with builders and air tightness testing for so many years, we know what the true results are and the builders that work at it. So 2.5 air changes is more like an Energy Star builder that's been working at that for years. It's nowhere near what a code built house is. If you were just to walk in and do an air test on a typical A1 package. The detached, well, SB12 says 3 air changes. National reference says 2.5. The 3 air change is pretty average. I said that's not so bad. When we're talking about detached homes, not so bad. When we start talking about attached homes and village homes like back-to-back or stacked MURBs, there is currently nothing in the OBC and currently nothing slated for the national that addresses air barriers on adjoining party walls. So you can imagine on a back-to-back middle unit, only one wall is exterior and the other 3 are attached. So, you know, we've been into stacked homes or 3-story slab on grade. That back-to-back is literally 9 air changes per hour. 9. Under Energy Star, they have the ACH approach. So an ACH air change per hour would be more about volume. But they also have the surface area approach, the NLR, which is, it came into factor because of attached homes. They tend to meet on NLR as opposed to ACH. So on Energy Star home, it might meet a 0.26 NLR, but we might see anywhere up from 3.5 to 4.5 ACH in a back-to-back slab on grade, which is actually a really good number compared to half of what we would expect from code. So from national, for one, they're not mandating air testing so far, and they're also not mandating air sealing of party walls. So it's going to be a long time before we can get to net zero at that pace, even though it's expected to be there by 2030. They might even move that up to 2050. But it's going to be a rocky road. So the good news for you guys is there's lots of opportunity within the construction industry because it's going to be so many changes. There's so many places that you could focus, HVAC and designing and energy and sustainability, and the biggest one coming now, carbon. That one's giving me a bit of a headache, but it's not just about greenhouse gas emissions anymore. Now it's all about carbon, and they're coming up with carbon calculators and oh, you name it. So the point is there's lots of opportunity, lots. And always learning. We're always learning.